For this problem, we're going to sketch the graph of the rational function we just looked at in the previous problem. So we want to sketch the graph of r of x equals x squared plus 2x minus 3 divided by x plus 1. On our graph, we're going to label the intercepts, vertical asymptotes, horizontal asymptotes, and oblique asymptotes. And then you can verify the results on a graphing utility. From the previous problem, we had the vertical asymptote was x equals negative 1. There were no horizontal asymptotes, and there's an oblique asymptote of y equals x plus 1. So next we're going to find our intercepts. We'll start with the x-intercepts. Remember, to find the x-intercepts, we let the function equal 0 and we solve the resulting equation. In this particular case, that means that we just really need to set the numerator equal to 0. So if the numerator is 0, then the whole expression is equal to 0. So we're going to set x squared plus 2x minus 3 equal to 0. And we solve that. So we'll get x plus 3 times x minus 1 equals 0. And so our x-intercepts will be x equals negative 3 and x equal to 1. We need to double check that we're not using any restricted values here. Our restricted value was x equals negative 1, which is neither one of these. So these are our x-intercepts. Next we'll find the y-intercept. To find the y-intercept, recall that we let x equal 0 in our function. And so if we do that, r of 0 equals 0 squared plus 2 times 0 minus 3 divided by 0 plus 1. And this works out to be negative 3. So our y-intercept is negative 3. It also is helpful to check for any symmetry. Now, since this is a function, it can't be symmetric around the x-axis because that would fail the vertical line test. But we can check for symmetry around the origin and around the y-axis. We're going to do that using the idea of even and odd functions. So first we're going to find r of negative x. So r of negative x will be negative x quantity squared plus 2 times negative x minus 3 and divided by negative x plus 1. That will give us x squared minus 2x minus 3 divided by negative x plus 1. Next we're going to see how r of negative x can help us determine symmetry around the y-axis and symmetry around the origin. We notice that r of negative x does not equal r of x, our original function. This means that the function is not even, and so it is not symmetric around the y-axis. Also notice that r of negative x is not equal to negative r of x, or the opposite of our original function, and so it is not an odd function. And so it is not symmetric through the origin. And again, we said that it can't be symmetric around the x-axis, or it would not be a function. Next, we're going to graph the function by hand. First thing we want to do to graph this rational function is to put in our asymptotes. We had a vertical asymptote at x equal to negative 1, so we're going to draw in a dotted vertical line to represent our asymptote. We also had an oblique asymptote, y equals x plus 1. We need to graph that line. So when x is 0, we'd get 1. When x is negative 1, we'd get 0. And so our oblique asymptote would look something like that. Next, we want to put in our intercepts. We found that we had x-intercepts at negative 3, so we want to plot that point, and also at positive 1. Then we had a y-intercept at negative 3, so we'll plot that point. We can use our asymptotes and the intercepts to help guide us as we draw in our rational function. So on this side, our graph will look something like that. And then on this side, graph will look roughly like that.